Okay, so when we're asked to find the perimeter of something, whether it be a triangle, quadrilateral, pentagon, whatever it is, the perimeter, as you all probably know by now, is essentially the distance around, okay? So the perimeter is the distance around any particular polygon. In this case, our polygon happens to be a triangle. Okay, so essentially in order to find the perimeter, we want to add side to side to side. So we have three sides, we're going to add them all together. Now one of the key words that we see here is the word isosceles. The reason this is a key word is because isosceles means that two of the three sides are the same length. So instead of calculating those sides twice, we only have to calculate one of those, and then we know that the other one's the same. As we look at our picture, we see that those two sides are here and here, AC and CB. So let's kind of get a little tally started here. We know that in order to find the perimeter, we need to know the distance of AC, we need to know the distance of CB, and those two are going to be the same, and we also need to know the distance of AB. And when we add all three of those together, we'll have a perimeter. Well, here's the thing about the side AB. Anytime that both of the endpoints fall on the same grid line, we're lucky enough to just simply count to see what the length is, how many units it is. So as I start here, I go 1, 2, 3, I keep going, 4, 5, 6, 7, 8, 9, 10. That is a length of 10. Boy, that's a heck of a lot easier than using the distance formula. But for the other two, we're going to have to use the distance formula because it's not on the same grid line, it goes across grid lines. So before we can really find the length of AC or CB, even though they're going to be the same, we need to identify their endpoints. So I'm going to start by going and counting to figure out, okay, that point A, what is its actual point? So I'm going to go to the left 1, 2, 3, 4, and then down 2. So that's a -4, -2. To find the actual point for C, I'm going to go to the right one and up 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the point 1, 9. So to find the distance between those, I'm going to use an x1, y1 down here for the point -4, -2. And I'm going to use, let me just kind of move this over here just to get out of the way. I'm going to use x2, y2 for the point 1, 9. So let's find the distance between those. Now, as I told you before we took the quiz, my advice when doing the distance formula is to do it like this. Put your minus in there, get everything set up, so all you have to do is just plug in the numbers and you don't have to worry about the signs. So, my x2 is up there, it's a 1. My x1 is a -4. My y2 is a 9, and my y1 is a -2. Now hopefully from earlier in the unit when we talked about doing these, you took my advice and said, okay, I can take and I can put all of this stuff that's under the radical in my calculator without the radical. Okay, now I don't even have a calculator handy here, so we're going to do it on this end without a calculator. Anytime you have a minus and negative, that becomes a plus. So really this becomes a 5 squared. 9 minus -2 is the same thing as 9 plus 2, which is an 11 squared. So now this distance becomes the square root of 5 squared is 25. 11 squared is 121. So the distance becomes the square root of 146. Okay, here's the thing. And I know that before we did our first quiz, I said, hey, I don't want decimals. I want you to go ahead and I want you to simplify that thing. You know, the square root of 146, that is something that we could simplify. But in this case, because we're looking to find the length around the triangle, we're not going to simplify that. So you kind of get the easy way out on this one. Because of the fact that this says round to the nearest hundredth, we're going to grab the calculator and we're going to put in the square root of 146. Oops, I'm not going to put an equal. When we approximate something, we use two tildes or two squiggly lines because that means we're approximating. And in this case, when I do the square root of 146, I get 12.08. The next number is a 3. And since I'm rounding to the nearest hundredth, which is 2 decimal places, it's this third number that helps me determine whether I'm going to keep the 8 as an 8 or I'm going to round it up to a 9. If that number to the right of the 8 is a 0 through a 4, then you just keep the 8 and 8, which in this case, that's what we're going to do. If that number were to be something 5 or bigger, we would round that up to a 9. So the length of AC is approximately 12.08. We know that CB is the exact same length because it's an isosceles triangle, and we know the length of AB is 10. So now we add all three together. That will give us a 34.16. That is the perimeter of the entire triangle.